Here we are, everybody, 5.6, multiplying and dividing a polynomial by a monomial. If we could start like we did in the last set of notes by dividing it into tiles and distributive, making a kind of chart like this. I'll talk about the tiles way here, and then I'll give you the distributive way as well, which I think is more versatile. But I'll give you both. So for tiles, let's start with our first step would be to put the polynomial on the horizontal of the table. Next step would be, and I'm actually going to call that the top as well. And next step, put the monomial on the vertical of the table. I guess this program doesn't believe that monomial is a word. I promise you it is. And finally, multiply corresponding tiles. And I'll show you what, I'll draw for you here what multiplying corresponding tiles would look like. So if we're going to have an x times an x, there's two different shape x's, but I promise you they're both x's, you would get an x squared. So x squared. That's an x. That's an x. If you have an x multiplied by a 1, so an x multiplied by 1, you get x. Okay, remember anything multiply itself is just itself. So I'll show you, I'm not going to show you a because this is just a constant, but I'll show you here. So let's kind of make a table like this. And on the top, let's put this one right here. So 3 v's. Remember, it could be x's, could be v's, doesn't matter. We draw them as the same shape if it's a single variable. And then let's draw the monomial on the side, that single v right there. So that's there. Those are there. And now we just kind of multiply each part by each other. So this v is going to multiply by this v. Remember, I have up here a variable multiplied by a variable is going to be the variable squared. So these are 3 v's. This is the v. This is a v squared. Now v times another v is going to be another v squared. And finally, a v times another v, be another v squared. You add them all up, we have 1, 2, 3, 3v squared. Okay. Now I will show you, maybe I'll just do a distributive one now. So I'll give you the definition here. And it's really just kind of the same as 5.5. So it's the same method. You just need to remember our very first unit when we learned about powers and how to multiply powers with the same base. So let me just put the instructions here. So distribute the multiplying monomial by each term inside the brackets. Okay, so I'll show you that one here. Maybe I'll give you a second to pause and write that down. So we're going to distribute the multiplying monomial by each term inside the brackets. So here we go. I'm going to now distribute this 5p. I'm going to multiply it by everything inside these brackets, or the two terms inside there. So 5p times -5, we just need to worry about these little numbers in the front. So 5 times -5 is -25p. And the next part, multiplying the 5p by the -2p. So let's first multiply the coefficients. So 5 times -2 is going to be -10. And this next part is when we have to remember all the way back to the beginning of the year. If we have p to the power of 1 times p to the power of 1, so we have powers with the same base, we can add the exponents. So it ends up being a p squared. Okay, so that's the hard part, to think all the way back to how we can multiply powers with the same base, and then you add the exponents. Okay, now let's look at, actually maybe I'll do these ones while we're here. So 3c times 5, we just need to do the 3 times the 5. It's going to be 15c. Let's multiply those two. That's actually kind of what we did actually in 5.5. Now again, this one we're going to multiply the m by the 7m squared. We're going to multiply the m by this negative 3. So it's going to be like m times 7m squared plus negative 3 times m. Okay, that's what we're doing here. So this right here, this has, remember, an invisible 1 right here. So 1 times 7 is just going to be 7. And now this m to the power of 1, we need to add this to the power of 2. So 1 plus 2 is going to be m cubed. Now let's deal with this part right here. We got a negative 3 times m, and that is going to give us a negative 3m. Okay, so that's that page. That's our multiplying. So now I'm going to show you the dividing. So I'll give you a few more notes right here. And I'll give you the steps for the tiles. So let's start right here. We need to put the dividing monomial on the horizontal. So that's the top. And then fill the inner table with the polynomial in even columns based on the horizontal. And then last step, solve for the vertical tiles, loop tiles. Okay, so basically answer, maybe I'll put that down, there you go. Okay, so I'll show you what this looks like, give you a second to copy that down, maybe I'll pause it for you, and then I'll show you an example on the next page. So let's see, which one do I want to do here? I mean, I guess we could do this one. So let's put this is, okay, I want to start here because these are just constants. So let's start here then. Let me show you this one. So first, let's start, let's make our table. Might need some more space. And then let's put our monomial at the top, so 2 z's. And then let's write this, and we're going to distribute it into the 2 kind of columns that we've just made here. So that means I'm going to want to put, here's 1 of my 2 of my z squareds. There's 3, 4 of my z squared. There's 5, 6 of my z squared. And here's 7, 8 of my z squared. I'm using up lots of space here, that's okay. And then we still need to put these 4 z's here. So I'm going to put 1, 2 of them. Now that kind of looks like a squared. Should make it skinnier, there we go. And then 3, 4 of them. And now we just kind of need to ask ourselves, how do we go, what would we need to have here in order to make this? So I know that in order to, this is a single, z, this is a single z. I know there would need to be a z here as well. So let me just draw that. So z times a z would give us a z squared, and a z times this z would give us a z squared. Again, we would need another z here to make a z squared. There we go, z, z. So we've got a z, a z, a z. And now to make these z's from, from this z up here, you would just need a 1 because you just wanted to make it into itself. Why isn't my pen working? Oh, it's not responding. Let me just pause my video for a second. Here we go. Okay, I think we're back. We back in business. Am I recording again? Let me check. Yeah, I think we're good. Okay, so we just need a 1 to multiply with this z to give us this z inside. So this is a 1 and this is a 1. So if we look what we have here, we have, let me just use a different color. We have 4 z's and we have 2 1's. So our answer here would be 4z plus 2. That's a z. So 1, 2, 3, 4 z's and 1, 2 of our 1's. So that's how you do it using the tiles. But, quite time consuming, doesn't work if you got a lot of, big numbers, and can get complicated if you have like xy or x cubed or things like that. So that's how you do it. And then I will show you here, I'll give you some notes for the distributive way to do it. And it's basically the same as 5.5 again. So you need to split the polynomial into separate fractions and reduce. Okay, but we are going to have to, again, remember what we learned in our very first unit about what it means to divide powers with the same exponent, and that we're going to need to subtract those. So let's do it here. I mean, this is a 5.5 question, but let's do it anyway. So this is a 5.5. This is a kind of 5.5. They're being divided by a constant, but let's do it anyway. So we're going to split this up into 2 fractions. It'd be 6x plus 3 divided by 3. So that's going to be 6x divided by 3 plus 3 divided by 3. Then we can just reduce this. 6 divided by 3 is 2x, and 3 divided by 3 is 1. Let's do this one. Might give myself a little bit of room by erasing some of this. Then we've got 14w subtract 7 divided by -7. Let's rewrite this over here. 14w divided by -7 plus -7 divided by -7. Now we just need to reduce this one here and this here. So 14 divided by -7 is going to give us -2w, and -7 divided by -7 is a +1. Okay. Now I'll do this one. This is a 5.6 question. We have a polynomial divided by a monomial. So I think, again, I might erase this to give myself a little bit of space. Okay, there we go. Hopefully you got that down. So I'm going to rewrite it as 12c squared subtract 6c divided by 3c. I'm going to rewrite it as 2 separate fractions. So 12c squared divided by 3c plus -6c divided by 3c. And now here's the part we need to, think way back to our first unit, and we're going to deal with each of these. So we're going to reduce this, and we need to deal with the c and the c squared, and we're going to reduce this, but we also can't forget about these ones, okay? So just going to, so let's do it. 12 divided by 3 is 4. We have a c squared divided by a c, which means we essentially have c squared minus 1, which is going to give us just a c, so c to the power of 1. And the next one, we have a -6 divided by 3 is a -2. If we had, there's a invisible 1 here and a visible 1 here. If we had c to the power of 1 minus 1, you would get c to the power of 0. Remember, anything to the power of 0 is just 1. So it just remains as -2. There's no variable anymore. So that's that one. And I'll do the last one for you. Oh, luckily lots of space to draw it out. So let's